Recording in progress.
Okay, let us start. So tonight we'll finish up the tutorial question on the system identification part. Now, before I start, remind you, someone email me, so I remind you again, the exam is closed book. Okay. But you can bring in one A4 size paper. You write anything on both sides. We don't care. Okay. And then Prof. Lee part is 35 marks. My part is 65 marks. So my part is more important, huh? Okay. Let us start. All right. Now, consider the system. So the system is like that. Now, then you have this measurement. So now find the least square estimate of this one, B1 and B2. So at t equals to 2, so you write down the simultaneous equation, t equals to 2. What do you have? You basically have, okay, at t equal to 2, y, which is 2, is equals to B1 times u t minus 1. So t minus 1 is 1. So it's 1 plus B2 u t minus 2 is 1. So it's 1. Then at t equals to 3, y is also 2 equals to B1. Then u at t minus 1 is 1. So it is 1. B2 at u t minus 2 is also 1. So at t equals to 4, y is 2 times B1 at t minus 1 is u3. So u3 is 1. Then B2, u2 is also 1. So this is 1. Then you remember, this is a simultaneous equation with two unknown B1 and B2. So if you look back at my tutorial question, at my introduction, all right. You have this. So this, last time also 3 equation. So you will write this down as y, and then the unknown theta 1, theta 2, or B1, B2 as theta, and the coefficient you put it in phi. All right, so you form this so that you know what is y, phi, and theta. So we do that. So obviously, this is y, which is this one, this vector here is y. Then equals to this one, B1, B2, and phi, you can write it as, so coefficient will be 1, 1, 1, 1, 1, 1. Then this is B1, B2. So in terms of my symbol, this would be phi, and this would be theta. Correct? Then, if you look at the formula for least square, the formula for least square was derived as this. We have a V, all right, which is, sorry, in the introduction that I teach you, we have a V, which is y minus phi theta transpose y minus phi theta transpose. And then the formula is this one. Because you dv d theta, you equate to 0, you get this one. So I just write down y minus phi theta transpose. So from there, here you have a V, which is y minus phi theta transpose y minus phi theta. And then remember, I derived for you dv d theta. What do you get? You basically get phi transpose phi theta plus phi transpose y equals to 0. I think so. This is a minus sign here. All right. And when you solve this, you will get your theta hat, which is then equals to phi transpose phi inverse. Okay, so these are the important equations. Now, so now you know what is phi, what is theta. You can easily solve for theta hat. But there will be a problem. You look at the solution, there will be a problem. All right, so just now we established what is phi, what is y. You'll find that, okay, V is this. Just now I wrote down y phi theta y phi theta. Now, your formula was theta hat is equals to phi transpose inverse phi transpose y. That is, if you can do an inverse of this, then you can solve for your B1, B2, your theta hat. But if you look at this phi transpose phi for our question is 3, 3, 3, 3. You will find that you cannot invert it. All right, you cannot invert it. So you cannot invert it means you cannot solve for theta. So what does that mean? If you go back and see where your V was like that, if you work this out, you will get this. In order to get the minimum, you equate. You can get the, because V is a square function, the minimum is 0. So if you equate this to 0, you can see that the minimum V is B1 plus B2 equals to 2. All right. If anything, and you cannot solve for B1, B2 because there's infinite solution. All right, so that's what it means. Your solution for the unknown is not unique. All right, if you cannot invert it. Now you can see, so that means what? V, you see, this was the equation. I think this is 15. If you look, this is 15. I got a typo error here. This equation is obtained when you do dv theta equals to 0. All right, you will get this equation. This equation, you see dv theta equals to 0 is this equation here. dv theta equals to 0 is this equation here. Phi transpose phi theta equals to phi transpose y is this equation here. You know that when you equate dv theta equals to 0, you are actually finding the minimum. So this one is phi transpose phi theta equals to, this is y, this is phi transpose. All right, this is the equation that will give you dv d theta equals to 0, or it will give you the minimum for V. This is secondary school maths. And you look at this equation, you get the equation 1 and equation 2 are exactly the same equation. And from here, you can see that whether you solve equation 1 or solve equation 2, this one gives you the same answer. B1 plus B2 equals to 2. All right. So 3B1 plus 3B2 equals to, this one should be 6. You will get B1 plus B2 equals to 2. So this equation does give you the minimum B because it's obtained from dv d theta. But if you cannot bring this one over to this side and invert it, then you cannot get B1, B2 unique solution. All right, so that's what the maths say. Then, now, question 3b shows you that if the signal is slightly different, so this tutorial question basically tells you that whether you can identify theta B1, B2 depends on the signal. Now you look, if the signal is slightly different, you look at this signal and this signal, same transfer function, you will find that 3b got no problem. You will be able to identify B1 and B2. So likewise, you go and find out what is your y, what is your phi, and what is your theta. If you do that, you will get three B. All right, your phi is this. Your y is this. This is your phi. This is your theta. This is your y. This is your phi. This is your theta. If you work it out, you will get this. All right. Just like before, dv d theta equals to 0, give you this equation. Now, it so happened that this one, you can bring it over to this side and invert it. That's why you will get B1 and B2 equals to 1, 1. So you can find for V minimum, you can get a unique B1 and B2. And you can see 1, 1. If you substitute 1 here and 1 here and 1 here, V is equals to 0. So, and V is a square function. So you know that 0 is a minimum. So B1 and B2 is equals to 1, you will get the minimum V. So in this question 3B, the message is that you can solve for the unknown B1, B2 if, in other words, say differently. Sometimes you cannot solve for the unknown B1, B2 because because of the signal, you don't have enough changes in the signal. All right. In the technical language, they say you don't have enough excitation. If you look at 3A, your signal don't change. So they are unable to identify the unknown. So there must be changes in signal. You see the signal didn't change. Whereas I just changed the signal from 0 to 1. So which means in practical system, if you find that you have problem in identifying, you may just want to change the input a little bit. And then you will get your output change a little bit. From there, you will be able to identify your plant. All right, this is the lesson behind the tutorial question. So this is about signal in identification. The next question is about modeling. So we assume that your real plant is this. So this is the real plant. Then what is a real plant? Real plant could be a heater. All right, could be a tank. So it's not a max. Real plant is a machine. So what you can do, every time you look at a machine, we'll write down a model. So you may think that the model of my heater is this. So you write down. This is the max describing the heater. Right, so you use this. But your heater actually behaves like that. Okay? We write max to represent it, but in reality, you where got max? You don't have max, you look, oh, heater. So all the max you have starts from here. It doesn't start from here. So basically, the message now is that you model your heater wrongly, basically. Your heater behaves like that, but you model like that. So now you want to use least square and identify A. We will show you what will happen if you do that. So these are all subtle, the tutorial questions are all subtle points in least square identification to help you such that when you get into trouble, you know where could be the problem. The signal, no change, not enough excitation, or the modeling is wrong. All right, so we see the modeling wrong. So what will happen? So now, if you write down your maths, the model like that, then you will start to do least square. So you do what? You will do let's say y1 will be equals to a hat y0 plus e0. You will write that. And y2 equals to a hat y1 plus e1 and dot dot dot. So to do your least square, you need to find out what is y, and because finally your least square formula looks like that. So you need to know what is phi and what is y. So it's obvious. This one here is your y. All right. So this is your y. Then what is, you know, y equals to phi theta. Theta is always the unknown. So you know unknown here is a hat. So a hat is your unknown. And then what's your phi? Phi would be this vector here. Of course, all this will be dot, 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 like that. Dot, dot, dot. So phi would be this vector here. So this vector would go to your phi. All right, this vector will go to your y. The unknown a here will be your theta. So after identify what is y, what is phi, then we will apply this standard formula to find least square. So if you stick y equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to t. This is y 0, 1, 2, 3, 4, 5, 6, all the way to t. And you stick it inside here. All right. And then this, you stick it as a. If you do all this maths manipulation, let's look at the solution. Okay, so there's a transpose here. Just like I told you what is y already, what is phi already. Sorry, it's not minus. They are all plus. Okay, so you know what is y, phi, theta, you stick it inside this formula, you work it out, it will look like that. All right, so these are just tedious algebra. I won't go through. You stick it inside, you'll find that it looks like that. This would be your A. But what is Y? Y, if it is a heater, would be the temperature and of your heater. And we say that actually the heater, the transfer function of the heater looks like that. All right, which is y equals to a yt minus 1 plus this one et plus c et minus 1. All right, you model it wrongly, but you measure the temperature, it is going to follow this formula. So see what happened. So now I stick it. I take psi to represent the rest. All right. So if you do that, then you stick in this psi inside here. you see this, you stick it inside here. All right, you will then get A hat equals to this. All right, you have to stick it in yourself. I will just give you the result. You just stick this inside here, then you'll find that it looks like that. Then after that, how to analyze this? This is what I would estimate equals to A is the true parameter of your heater plus something else plus what? So we want to find out. The best is this is 0, then the head, what you estimate is equals to what is true. So we want to find out what is this. So assuming large T and the system is ergodic. Ergodic means basically you find the expectation is the same as finding the time average. So this is summation up to T, and T is large. So if you divide the numerator by T, you divide the denominator by T, you have not changed this expression at all. And now you are finding the average of this and the average of this. And since we assume that it is ergodic, which is statistics term, is basically the expectation is the same as the time average. Then it's the same as finding the expectation of this, the expectation of this. This is the same as this. This is the time average. So now we will find out what is the expectation of this, expectation of this. Then you put it inside. And hopefully it is 0, then you will see that A hat is equals to A. So before we do that, we have to do some maths first. So from equation 2, all right, before we can find out what is the expectation, we need to find out some expectation of the noise first. From equation 2, 2 is the expression for psi. So expectation of psi times psi is equals to this. How you get that? Now, you psi times psi. So expectation of psi times psi is, you just multiply this thing. All right, so you expand this, you will then get this is E square plus 2C E T E T minus 1 plus E T minus 1 square. Now it's given in the question that the variance of the error signal is sigma. So the expectation of this would then be sigma. So you will get sigma square here. All right. And this one is also plus sigma square. Sorry, there's a C square here. plus C square sigma square. Then it is also given the question that the noise term are independent, which means this is zero mean, this is zero mean, and this is independent of this. So you find the expectation of two random variable multiplied together, they are independent of each other, and each one of zero mean, you will find that this expectation of this is zero. Okay, so this would be plus 0 plus this. So that's how you get expectation of psi is sigma square plus C square sigma square. Okay, here. Then you need to find, before you can find out this, you need to do all this maths, then later you can substitute inside. You need to find the expectation of sigma square, sorry, sigma expectation of zeta t and zeta t minus 1. So we will do that. Likewise, we will do that as before. Expectation of zeta and zeta t minus 1, which is this one here. All right. Zeta would be this one here. So is expectation E t plus C E t minus 1. Then zeta t minus 1 must be E t minus 1 plus C E t minus 2. Okay, so if you multiply things out, you will then get equals expectation of, you will get this times this is E t minus 1. This times this is plus C E t minus 2 plus this times this is C E t minus 1 square, then plus this is C square E t minus 1 E t minus 2. Okay, so again, because given the variance of E is sigma, so you see a square, you know it is sigma. So expectation of this one is C sigma square. Then you know that they are zero mean and independent. So this is zero mean, this is zero mean, and this sample has nothing to do with this sample. So you take the expectations, it will be 0. So as long as t are not the same, this will be 0, this will be 0, this will be 0. This is because the t are the same, the variance will be sigma square. So the rest are all 0. So this is 0 plus 0 plus 0. So it is this one. So that's how you get this result here. Then you can continue and do if t and t minus 2, t minus 3, this t minus 1, t minus 2, t minus 3, you find that here they are all 0. You don't get any square terms. All right, so as long as time difference is by more than 1, it's all 0. The expectation. All right, so we worked so hard up to here. Then now the next thing we want to do is, okay, we need to find out if we assume that the first sample y0 is 0, then what is y1? So you use equation 1 and 2. So if the first sample is 0, then y1 would just be zeta 1. So you get y1 equals to zeta 1. Then after that, what is y2? So you look at y2. Y2 would be y1, so a times zeta 1 plus zeta 2. So you will then get this. All right, then you go back and look at this. What is y3? What is it? Yeah, what is y3? Then you will get this. So now you got your y all in terms of zeta. It will not be difficult for you to see. If you work hard enough, you will see the pattern. Yt minus 1 is always equal to zeta t minus 1. It's just like y3 equals zeta 3 plus a, you see there's a, times zeta t minus 2 plus a square zeta t minus 3. Dot, 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 dot. You will see a pattern. If you work hard enough, do y4, y5, you find that you have a general pattern here. Okay, so now you have this general pattern. Then now we can find out what is, you see, we want to solve this. So we can now find out what is this. You will find that this is actually equals to this. How we get that? So this, we substitute this inside here, you'll find that the expectation of this with respect to this is here. This times this term, because it differs by 2 is 0. Then obviously this one t minus 3 differs by 3 is 0. So when this times this, after you substitute this, it's just this. And when we have found the result for this, it's just c sigma squared. Right? This, you basically stick that inside here. You find that expectation because of zeta I times the I minus 2, I minus 3, or t minus 2, t minus 3, it doesn't matter. You will get 0. So you will just get this, and this we previously found the expectation was like that. C sigma squared. And so you know the numerator here is C sigma squared. So you found the answer for the numerator. And then you need to find the answer for the denominator. Answer for denominator is expectation of y I squared, I minus 1 squared. So all you need to do is work hard a little bit. Let me find a space. This one here. This one here. must be equals to expectation of this one, yt minus 1 is equals to this. So I take this. Okay. Then you just work hard and multiply this out. Then go and find, if the expectation of this times this, as long as it's a square, you will get this one. All right, you will get this one here. If the index differ by 1, you get this one. If the index is more than 1, or 0. So we just multiply out a bit to see the pattern. So this one should be equals to, you will have this square. So there will be a value here. Then this times this, you will also have a value a. Then this times this, you will get 0. Just write it down. Okay, 3. All right. Then plus this one times this, you will get a value. Because when the index differ by 1, you get a value. Then this one times itself, you also get a value. You see a square, you get a value. Then this one times this one, you will get a value because the index differ by 1. Okay, I just do one more row so that, and then this one times this, you will not get, and you will get 0 because the index differ by 2. This one times this, then this one multiplied by itself, you will get a value. And dot, dot, dot. All right, if you work, so you know if the index differ by 2, we previously showed that it is 0. If the index differ by 1, you get C sigma square. If it is a square, then you also get a value here. So you go and see this one, you get value, this one, you get value, this one, you get 0. So after a while, you will see a pattern. And then you will see, basically there are only two types of value. One type of value is the square type, which is this one. The square type is this one. 1 plus C square sigma square. The differ by 1 time is C sigma square. So you find that the differ by one type, you got all this add up together. The square type, you have all this add up together. All right, the pattern here. So you know, we already got the value for this, we got the value for this, and then after that, you see that these are APGP kind of summation. So you got the formula, you write down the formula for that. All right, this type of summation, the formula for this type of summation is actually one over one minus a squared. All right, same as this. A is less than 1. All right, the summation for this is also the same. And this one, we earlier found out the expectation of this is C sigma square. And we found out the expectation of this was what? 1 plus C square sigma square. All right. So you stick all these things together, you'll find that it's this. Then now you got this, you substitute this into the denominator there. Here. All right. Then if you do that, you will then get A hat equals to A C1 minus A squared over this. So it is clear. You are not going to get the correct result unless C is 0. If C is 0, what does it mean? It means that you model correctly. Because where's the question? The question basically says all right, if the real plant C is 0, then you model your model and the real plant match. Then you get A equals to A. If it doesn't match, then this A is not your A. Okay, last question. Now, last question. Look at. Okay, this one, your plant has this transfer function. Then you have a controller. Your controller is calculated like that. All right, the current control input, the current control signal is equal to the previous control signal minus the output. So now you apply least square. You want to estimate the A, B, and B1. There's no A2. So you want to estimate this. Show that it cannot be uniquely determined. All right. That's for A. So you do the standard thing and you find that A, it cannot be uniquely determined. How? All right. So from here, likewise, you go and write down a few equations to see for yourself what is phi equals to d. What is y, what is phi, what is theta. Okay, just to make things simple without going into too complicated maths, I just write down 3 equations. So I just write down 3 equations for you. The 5 or 3 equation looks like that. You should be able to write down already. So which means you just write down the first 3 equations and you get the 5 after 3 equations. Okay? Then you know that to get unique estimate, to get unique estimate, we say before, this must be invertible. All right, if you cannot invert this, then you just cannot find this. You can find the minimum V. All right. And the minimum V is you can find, but you cannot find there's a infinite solution to theta. You cannot find a unique solution to theta. All right. So to whether this is invertible or not, all you need to do is to find the determinant of this. So you find the determinant of this, which is equal to this. Then don't forget there's a controller. The controller was given by this equation. All right, u is equals to the previous u, then minus y or something like that. So this was the controller. So the controller do calculation like that. And this is the determinant of phi. If you see got y here, you stick this inside here. You stick all this inside here. Of course, t plus 1, you got to do plus 1 here. T minus 1, you go minus 1, minus 1, minus 1. You find, hey, the determinant equals to 0. So determinant equals to 0 means that theta is singular. You cannot invert this, and the estimate are not unique. So again, this is to tell you, hey, if you implement it, then you put in feedback control that, hey, how come I got no result? MATLAB give me things that are so funny. Okay? Because of your feedback. It causes your determinant to be equal to 0. So one simple way is to change your controller slightly. So the question, just change the controller slightly. If you go back, all right. The controller now for E is changed to this. So no longer this controller, you change to a more complicated controller. If you do this, then you substitute Y into the determinant. Okay, you substitute Y into the determinant. Now you'll find that the determinant may not be equal to 0. You substitute Y, this Y into here, you find that the determinant is this. So now it all depends on you, your control signal. If your control signal put inside this equation give you non-zero, your determinant is non-zero, and so you can estimate your unique theta. All right. Whereas if you use this simple controller, this first controller here, you substitute inside here, you find that it will straight away give you 0. All your u will all disappear. It will just equals to 0. There's no way that you can identify this system if you use this controller. All right, but if you use this controller, then you now have a chance. Depends on your signal. Of course, you can choose signals such that substitute inside here will give you 0. Again, you cannot identify theta uniquely. But now you have a chance to generate U such that this is not equal to 0, and therefore you can identify theta. In this first case, when with this simple controller, you got no chance. Once you substitute inside, all disappear, all cancel away, and determinant of theta equals to 0, phi equals to 0, and theta will not be unique. Okay, I finished everything that I want to teach you. Are there any question? Any question? All right, if not, then I will see you. Good luck for your exam. My part is more important. Okay, bye-bye.